Welcome to PanGlobal's Correction Series, which features typical calculation problems and their suggested solutions from our subject matter experts. In this video, we'll work step by step through a problem that our technical staff have devised to help you apply the knowledge and concepts gained from your PanGlobal learning materials. This week, we are looking at an example of linear expansion of a pipe. Almost all solids expand when undergoing a temperature increase. If the process fluid in a pipe has its temperature increased, the steel pipe will expand in the radial and linear directions. The linear expansion of a pipe must be accounted for in the piping design phase of an engineering project. Components such as pipe supports or pipe hangers with springs are used to allow for pipe movement. Expansion loops in long runs of pipes are also used. The following problem provides some insight into the calculations required to determine this expansion. Defining the problem. A mild steel pipe that transports saturated steam at 800 kilopascals absolute pressure will be used to transport saturated steam at 1,200 kilopascals absolute pressure. Assume the pipe and any fittings are rated for the increased steam pressure and temperature. After the steam pressure is increased, the change in steam's pipe length is 13.6 millimeters. What was the original length of the steam pipe in meters? Pause the video now to work through the problem on your own, or keep watching for the step-by-step solution. Identifying the equation. Change in pipe length may be determined using the formula delta L equals L original times alpha ms times delta T. Delta T is the difference in temperature found by subtracting T2 minus T1. In this formula, delta L is the change in pipe length in millimeters. L naught is the original pipe length in millimeters. Alpha ms is the coefficient of linear expansion of the mild steel per degree Celsius. T2 is the final temperature of the pipe in degrees Celsius. T1 is the initial temperature of the pipe in degrees Celsius. Identifying known and unknown information. The original length of the pipe is unknown. The change in length of the pipe is 13.6 millimeters. The coefficient of linear expansion of mild steel is 12.0 times 10 to the power of negative 6 per degree Celsius for a temperature range of 0 degrees Celsius to 100 degrees Celsius. This value is obtained using the specific heat and linear expansion of solids table in the PanGlobal Academic Supplement Edition 2.0. For the purposes of this solution, assume this value can be used even though the steam temperatures are higher than 100 degrees Celsius. The final temperature is 187.99 degrees Celsius. This temperature is obtained using the saturated steam table in the PanGlobal Academic Supplement Edition 2.0 for steam at 1,200 kilopascals absolute pressure. The initial temperature is 170.43 degrees Celsius. This temperature is obtained using the saturated steam table in the PanGlobal Academic Supplement Edition 2.0 for steam at 800 kilopascals absolute pressure. Solving the problem. The above equation must first be transposed to solve for the unknown variable. The unknown variable is the original length of pipe, L original. The original length must be isolated on one side of the equation with all the known variables on the other side of the equation. process of transposition involves a systematic approach of mathematical operations to isolate the unknown variable on one side of the equation. Just remember, any mathematical operation that is done to one side of the equation must be done to the other side as well. First, divide both sides by alpha ms. Then cancel the variables that are the same in the numerator and denominator. Next, divide both sides by delta t and cancel the variables that are the same in the numerator and denominator. Move the unknown variable to the left-hand side of the equation and the known variables to the right-hand side. Finally, write delta t in its expanded form, t2 minus t1. The formula is now ready to be used. Enter the known information into the equation. Solving the right-hand side gives an answer of 64,540.6 millimeters. As the question requires the length of pipe, we multiply this answer by the conversion factor of 1 meter over 1,000 millimeters. Doing so provides the final answer of 64.5 meters. This was the initial length of the steam pipe specified in the question.